Option Y on Mac or Alt Y on Windows if you have any questions for Bill Alek. And once we work through those, then we have Wayne Ojala coming up.
I hope I didn't shock everyone.
No, no, there's Michael Boyd. Sir?
Michael. No, he's gone. Oh,
there I am.
There you are.
Okay, yeah, that was pretty cool. I really liked the part where you showed how the equation changed with and without mass. That was kind of impressive to me. I
was stunned myself when I saw that. I'm going, there it is. That's the scalar wave component that's in, the quantum field theory. It's there, but they don't recognize it as such. Okay. They don't see it as a scalar wave function.
Well, my question is, could you have a scalar wave of the opposite polarity from basically the absence of mass?
Yes. Well, one station's transmitting a positive going wave, and the other one, it's electromagnetic, okay? And the other station's transmitting a negative going electromagnetic wave. And when you do the math, you sum up the math, the interferometry creates a region of strong electromagnetic field energy. And that's what Tom spoke about, is that the two waves combine, okay? Only in that region, they mix.
Thanks. I appreciate your answer.
Okay. Yeah,
so gravity too.
Let me go to Mark Sokol now. Mark?
Yes, Bill, I'm just wondering, what do you consider to be a scalar field? Because on one hand, we're talking about particles, which are, tiny little spheres that can have a potential that goes out in all directions. And on the other hand, you have this transformer, which I don't see any way that it could possibly have a scalar field, because there's always going to be a vector to it.
Well, you see, what Tom spoke about is this opposing field action. You have to have that, and it's set up in the flux of the material, is that you set up your currents and voltages in the two coils such that it's setting up this opposing flux action. Tesla did the same thing.
But that's not scalar. That's just opposing. Those are two vector fields. They're like two dipoles. Like a regular dipole antenna that you have would have two dipoles going out from each side. It would be positive in the center, negative on the outside, and then negative in the center, positive on the outside. That's a dipole antenna, what you just described. A true scalar field is a sphere that has potential from the inside of the sphere to the outside of the sphere, and then out to the universe. So it can't be connected to anything metallic, or that would become a dipole, or near anything metallic, because then it would be a dipole to what's near it. Okay. So I don't think you're using the correct definitions of the terms.
Okay, well, this is what I understand from Tom in his lectures. Okay, and his MEG device that he set up this opposing action, in his MEG, and then I see it in other devices as well. Tesla used this opposing field action, magnetic fields, in his transformers. Stanley Myers in his transformers set it up as well. And then I see it as a trace. Okay, that blue trace is a sum of the input current plus the reactive component from the transformer, which is your sine squared term. That's your opposing field action. Okay, the sine squared term is what you're looking for, and that's the scalar component, the scalar wave. And the two add electromagnetically, and you get that complex wavy pattern.
That
Okay,
complex
but I'm
wavy
showing-
pattern is a regular AC field that's been screwed around with. If you have a true scalar field, will be measured by the distance to the object in all directions. And if it was an AC scalar field, that would be alternating, but it would be alternating the same in all directions. Scalar means that it's going in all, like the planet Earth we are living in a scalar field right now. Gravity is a scalar field. The ionosphere is a scalar field.
Right.
It's also a scalar capacitor because it's all the way in a circle. There's actually a guy on the YouTube channel right now, Daniel Foster, who actually built an AC scalar field generator by putting the transformer inside of the sphere with a battery. So the conductor was surrounding the transformer with the power supply in it. That will create a true scalar field. What you're creating is just dipole moments. Also, are you still claiming that the transformer was over unity?
No.
Okay.
No, I'm just seeing that it's higher efficiency than a normal transformer would be.
Okay, I would encourage you to try a true watt test with a light bulb.
Okay, well, I'm using a resistor, just a resistor network.
Are you measuring the heat then to get your watt measurement?
Oh, yeah. Yeah. Yeah, the temperature. Yes. Yes, it does get quite hot.
So you're measuring the coulombs coming out in order to convert that into watts, or are you using a watt meter?
Just mainly with watts. Just looking at the wattage calculations.
Right, because the wattage calculations won't be accurate for something like that, especially with an AC field that's not a true sine. It won't be accurate anymore. And if you hook that up to your power line, it can confuse the power meter from the utility as well.
Oh, well, you definitely don't want it connected to the grid. You know, this sort of technology.
No, it'll screw up with electronics in your home and probably your neighbor's home as well. And you might get a citation from the power company. I see you're smiling, yes, and the reason for that is that it can screw around with everyone.
I find it to be a great research project, but that is interesting. Okay, trying to set up a spherical type of arrangement.
Yes, like a ball lightning is an example of a scalar field. It's in all directions. Regular lightning, that's dipole. You got positive, negative, or vice versa. With ball lightning, it's all punched in there in one spot. An electron, scalar field. That's literally what it is.
Right. Agreed.
Okay, so let's do option Y on Mac or Alt Y on Windows for questions for Bill. And we are just at the top of the hour. So if we don't have any, we'll give it another minute here. Then we can go to Mr. Wayne Ojala, who has been with us. Okay, well, so let's do that then. Okay, so let me put this thing back on gallery view. Everybody, please give Bill another applause. Guys, thank you so much. Thank you so much. Again, it feels like we're getting our energy back here. Let me go to Wayne. If I can spell his name right. Oh, fail forward research. Okay, I'm going to go ask to unmute. So with Wayne Ojala, he is saying that